You're driving across the Sunshine Skyway and you don't know what's wrong yet. You just feel it. The way the wind shoves your car sideways, the way the rails look smaller than they should. 50,000 cars a day cross this bridge, and most drivers have no idea it's been inspected 47 times in 5 years. Engineers call it structurally obsolete. They let you drive it anyway. The cables holding you 200 feet above Tampa Bay are thinning 3 times faster than anyone expected. You can't see them. They're inside sealed boxes that were supposed to stay dry forever. They've been dripping with salt water for 18 years. Here's the thing that should scare you more. 7 other Florida bridges have the exact same hidden flaw, and one of them already collapsed. You're still on the Sunshine Skyway, and here's what they don't tell you at the toll booth. Those cables are steel wires twisted together, wrapped in grout, and then wrapped again. Florida humidity pulls moisture into micro cracks you'd need a microscope to see. Once that salt water gets inside, the grout turns into a wet sponge. The cables rust from the inside out. In 2022, state inspectors found 11% strength loss in the main cables. 11% gone, and you'd never know. 34,000 people cross here every day. Engineers say if 3 cables snap in sequence, the tower tilts 4 feet and the deck drops. They installed dehumidifiers on 6 of the 21 cable sets. The rest are still getting wet. They reduced the speed limit to 45, wind restrictions at 40. But their own 2025 report admits they have monitoring gaps. And that's not even the worst part. The Skyway has a warning system. Most Florida bridges have nothing. Take the Roosevelt Bridge over the St. Lucie River. 65,000 cars a day. You drive across it, and you'd never guess the support columns are dissolving 4 times faster than predicted. State inspectors don't even know why. They just know the concrete piers standing in that brackish water are falling apart from the inside. Here's what that looks like. Salt water reacts with chemicals inside the concrete. The concrete expands, cracks. Water reaches the steel rebar. Rebar rusts. Rust takes up 6 times more space than steel, so the concrete explodes from within. In 2023, they sent a sonar boat to look inside those piers. 8 of the 24 showed internal cracking so severe engineers couldn't measure how deep it went. If 3 of those piers fail at the same time, the whole bridge twists. The deck separates at the expansion joints and cars fall through. The fix costs $47 million and would shut the bridge for 14 months. Current budget $0. The bridge is number 127 on the priority list. They check it every 2 years with flashlights. Now get off the big bridges and go somewhere nobody's watching. Matanzas Pass in Fort Myers Beach. You've driven over wooden bridges in Florida and thought they were replaced decades ago. 347 of them are still active. This one was built in 1927. The main supports are creosote-treated pine. The treatment wears off after 40 years. These pilings are 97 years old. Down in the mud, marine borers are eating the wood from inside. Shipworms, gribbles, little crustaceans that get in through cracks smaller than a human hair and chew tunnels. The bridge looks solid outside. Inside, it's a honeycomb. In 2024, they drilled into the pilings and found 60% hollowness on 11 of the 32 supports. Load capacity drops 80% before the outside even cracks. 8,200 cars cross here every day. There's a school bus route. The weight limit is 15 tons. Loaded cement trucks weigh 25, and they cross it weekly. The state put temporary steel beams around the rotten wood and called it shoring. Replacement planned for 2028. $18 million. They issued a letter saying no imminent danger. Same language they used before the Minnesota bridge collapsed and killed 13 people. You think inspectors can see all of this? The real nightmare is underwater. Watch Hurricane Ian in 2022. The Sanibel Causeway didn't collapse from wind. It collapsed from below. Every Florida coastal bridge with piers in sand or mud has the same vulnerability. The Pensacola Bay Bridge, 3 miles long, 60,000 cars a day. When fast-moving water pulls the soil away from pier foundations, that's called scour. Hurricane currents can move 8 to 10 feet of soil in 6 hours. Those piers were designed to be buried 15 feet deep. After a storm, they might have 3 feet left. The bridge stands because the soil pushes sideways against the piers. Remove the soil and the pier becomes a flagpole. Concrete fractures at the mudline. The deck above looks fine, but the foundation is gone. After Ian, they found 14 Florida bridges with scour deeper than design allowed. Engineers call them fracture critical. One pier fails, the whole span drops. Here's what FDOT doesn't tell you. They only inspect scour every 5 years. Hurricanes happen every year. The permanent fix requires full closure, 18 months and $50 million per bridge. Florida has plans for 63% of the at-risk spans. The rest are just sitting there. Now here's the part Florida refuses to talk about. Every steel bridge built between 1975 and 1995 has a manufacturing defect engineers knew about in 1986. Take the Fuller Warren Bridge in Jacksonville. I-95 over the St. Johns River, 165,000 cars a day, built in 1989. The welds were made with the wrong temperature control. Hydrogen got trapped inside the steel. Now, those welds are cracking at 40% of their designed strength. The 2023 inspection found 347 cracks, 89 of them critical. Engineers measured this problem in 1988. They opened the bridge in 1989 and signed off anyway. Those cracks start microscopic and grow 1 millimeter per month under load. After 10 years, you can see them. After 20 years, they're structural. Florida has a welding crack database, 1,800 active cracks across 43 bridges. No public disclosure, just monitoring. The repair for the Fuller Warren alone costs $120 million. Nobody's paying it. And here's where the physics gets terrifying. Florida heat doesn't just make you sweat. It's prying bridges apart 2 inches every summer day. The Howard Franklin Bridge in Tampa, 120,000 cars daily. Steel expands in heat and contracts at night. A 1,000-foot bridge swinging 40 degrees every day moves half an inch each cycle. 50 years is 18,000 cycles of expansion and contraction. Every cycle loosens bolts, widens cracks, and work hardens the steel until it snaps. The bridge has expansion joints designed to absorb that movement. Florida joints clog with sand and asphalt and debris. When the joint jams, the steel still has to move somewhere, so it buckles upward or crushes the concrete next to it. In 2019, inspectors found bridge bearings frozen solid on 23 Florida bridges. Bearings are the sliding plates that let the bridge move. Those bridges were bending steel instead of sliding. In 2021, an I-4 overpass developed a 4-inch deflection during an August afternoon. Closed 6 days. The state spends $3.2 million a year on joint cleaning. They need $11 million. 67 bridges are waiting for frozen bearings to be fixed. The next Florida heat wave is projected to be 3 degrees hotter by 2035. Expansion will increase 30%. The slowest failure is also the deadliest. Every concrete bridge in Florida has a death date stamped inside it. Engineers know exactly when. They just can't stop it. The Gandy Bridge in Tampa, 50,000 cars a day, built in 1997. Saltwater pushes chloride ions into the concrete. They move about 1 inch every 5 years. When those chlorides reach the steel rebar 2 to 3 inches deep, they trigger corrosion no matter how strong the concrete is. Once it starts, it accelerates. After 10 years, the rebar loses half its diameter. Concrete protects rebar by being naturally alkaline. Chlorides destroy that protection. Rust takes up 6 times more volume than steel, so the concrete cracks from the inside and the cracks let in more chlorides. Feedback loop. In 2024, FDOT found 39 bridges where chlorides have already reached rebar depth. Once that happens, the bridge has 10 to 15 years left, and no repair can save it. Replacing those 39 bridges costs $1.2 billion. Here's the part they don't put in press releases. Adding new concrete on top actually traps the chlorides against the rebar. It accelerates failure. They've installed electric cathodic protection on 8 bridges at $5 to $10 million each. The 2025 budget has $40 million for this problem statewide. They need $400 million. Now take all of those failures and imagine them happening at the same time. Engineers have a name for what keeps them awake. They call it cascading evacuation failure. Tampa Bay has 3 bridges: the Sunshine Skyway, the Howard Franklin, the Gandy. 3 million people in 7 evacuation zones. Here's the nightmare FDOT modeled internally in 2023. A Category 4 hurricane approaches. 72 hours before landfall, they order evacuation. The Skyway closes at 60-mile-per-hour winds, but wind restrictions kick in at 45. The Howard Franklin is already speed restricted because of weld cracks. The Gandy's chloride-damaged rebar can't handle stop-and-go evacuation traffic. The weight, the heat. One bridge closes and traffic shifts to the remaining 2. The overload accelerates their failures. Second bridge closes. Now one bridge has to handle 3 million people. 18-hour evacuation times. Storm surge arrives before 40% of the population clears the zones. FDOT's own modeling shows 3,200 to 7,800 fatalities in the worst cascade. Their current plan is called redundancy. It means they hope all three stay open. In the 2024 evacuation drill, the bridges performed as designed. Engineers noted there was no margin for unexpected closures. One crack changes everything. One stuck bearing. One scour event. There's no funding for parallel bridge construction. That would cost $4 to $6 billion. So why does Florida keep building the same vulnerable bridges? Every new bridge under construction today uses the same designs. The new Tampa Bay Bridge opens in 2027, cost $1.2 billion. This brand new bridge will have the exact same scour vulnerability, chloride problems, and weld risks as the bridge it's replacing. Florida DOT designs for a 75-year lifespan and minimizes initial cost. Corrosion-resistant epoxy rebar costs 40% more upfront, but saves 300% over the lifespan. Florida chooses epoxy on 23% of its projects. Utah uses it on 89%. Engineers say life cycle cost analysis. Then they build with standard rebar, standard concrete, standard welds, because the first 10 years of maintenance comes from federal money, and long-term replacement comes from some future budget that doesn't exist yet. They know exactly how to build bridges that last 150 years in Florida saltwater. Those bridges cost 60% more today. Today's budget committee doesn't care about 2095. The national bridge repair backlog is $125 billion. Annual spending is $14 billion. The gap widens $5 billion every year. Every bridge in this video will reach failure before 2050. Replacement cost if done today, $8.7 billion just in Florida. Replacement cost if done in 2045 after failures start $47 billion plus lives. The Sunshine Skyway collapsed once. Engineers promised it would never happen again. Today's inspections show it's failing faster than any model predicted. And the new bridges being built right now are using the same math. 15,000 American bridges are in imminent failure category according to federal data. Not one has been replaced this year. Not one has a fully funded repair plan. Engineers drive over them every morning. So do you. So do their kids. The only thing holding these bridges up isn't steel or concrete anymore. It's the assumption that they'll hold. Just one more day. Just one more car. Just one more hurricane season.